Right now, sitting on your shelf or in your garage, there is probably a bag of fertilizer. Maybe it says nitrogen, maybe NPK, maybe it has a brand name and a price tag and a picture of healthy green vegetables on the front, and you bought it because someone told you your soil needs it. But here's what nobody in the fertilizer industry wants you to know. There is a patch of soil in the Amazon rainforest that has been producing crops continuously for over 2,000 years. With zero synthetic fertilizer, zero chemical inputs, and zero modern agricultural technology of any kind. It is darker than the soil around it, richer, more alive, and the civilization that created it figured out how to make it self-sustaining before the Roman Empire even reached its peak. The fertilizer industry is worth $207 billion a year, and its single biggest threat is a 2,000-year-old pile of charcoal. This is the story of Terra Preta. To understand why this matters, you have to understand something about the Amazon that surprises almost everyone who learns it. The Amazon rainforest, one of the most biologically productive places on Earth, sits on some of the worst farmable soil in the world. The tropical heat and constant rainfall destroy organic matter before it can accumulate. Nutrients get leached out almost immediately. The result is thin, acidic, nutrient-poor red and yellow clay that bakes hard when you clear it and becomes almost useless within a season or two of farming. This is why, for most of the 20th century, scientists assumed that large, permanent civilizations simply could not have existed deep in the Amazon. The soil would not support them. So when Spanish explorer Francisco de Orellana sailed the Amazon River in 1542 and came back with stories of great walled cities, dense settlements, and vast gardens stretching for miles along the riverbanks, historians dismissed it as fantasy, as exaggeration, as the kind of tall tale explorers tell when they want more funding. But then they started finding the soil. In the 1960s, a Dutch soil scientist named Wim Sombroek was working in the Amazon basin studying soil composition. In certain areas near the ruins of ancient settlements, he kept finding something that should not have been there. Patches of deep black earth, dense, rich, and almost impossibly fertile, cut through the surrounding clay like dark islands in an orange sea. The locals had always known about it. They called it Terra Preta do Indio, the black earth of the Indians, and they had been using it to grow vegetables for generations without ever quite understanding why it was so different. Sombroek understood immediately that this was not a natural formation. This soil had been made. He could tell from the pottery shards mixed through it, from the fish bones and animal remains layered into its structure, from the way its depth and boundaries corresponded precisely to ancient human settlements. Someone had deliberately engineered the soil. Whatever they had done, it had not just survived for 2,000 years. It had continued to actively regenerate itself. The fertility had not depleted. It had compounded. He spent the rest of his life trying to figure out how. The key ingredient was not the fish bones, not the pottery, not the organic matter, as useful as all of that was. The key ingredient was charcoal, but not the charcoal you use on a grill. Low-temperature charcoal, wood burned slowly in low oxygen conditions, a process now called pyrolysis, producing a porous, carbon-rich material that behaves completely differently from ash or soot. When this charcoal was mixed into soil, it didn't just decompose and disappear the way normal organic matter does. It stayed. Its structure, riddled with microscopic pores the way a sponge is riddled with holes, created a permanent habitat for the beneficial bacteria and fungi that plants depend on for nutrient uptake. It held water in dry spells. It held nutrients during heavy rain instead of letting them wash away. And because it was structurally stable, the carbon locked inside it stayed locked, not released back into the atmosphere as CO2, but stored in the ground for centuries. Possibly millennia, the patches of Terra Preta that Sombroek found in the 1960s are still there today, still fertile, still producing. The charcoal mixed into them is 2,000 years old, and it is still working. When Professor Johannes Lehmann at Cornell University started running controlled trials on biochar, the modern name for this ancient material, in the early 2000s, the results were striking enough to trigger what researchers now call a biochar renaissance. By 2017, the number of scientific papers published annually on biochar had exceeded the number published on compost. Laboratories on 6 continents were running field trials. The findings kept confirming what the Amazon soil had been demonstrating for 2 millennia. Biochar, when properly charged with nutrients and mixed into degraded soil, increases crop yields. It reduces the need for synthetic fertilizer. It sequesters carbon stably for hundreds of years. Every pound of biochar applied to soil removes roughly 2 pounds of carbon dioxide equivalent from the atmosphere. So here's where the story gets uncomfortable. We have a soil amendment that has been field tested for 2,000 years, is confirmed by modern science, improves crop yields, reduces fertilizer dependence, sequesters carbon, and can be made at home from agricultural waste at essentially zero cost. And the global fertilizer industry, currently valued at over $200 billion, requires that you not know about it, not that they've buried it, not that there's a conspiracy room with men in suits deciding what soil amendments get publicized. It's simpler and more boring than that. The fertilizer industry advertises, it funds agricultural extension programs, it sponsors the conferences where farming recommendations are made, it sells a product that works fast and produces visible results. Biochar requires patience, it requires understanding, it requires making something rather than buying something. And there's no $200 billion industry with a financial interest in you knowing how. Meanwhile, in parts of Brazil, the situation around actual Terra Preta sites is becoming genuinely alarming. Because the soil is so extraordinarily fertile, local traders have begun mining and selling it as potting mix in informal markets, effectively excavating 2,000-year-old archaeological sites for garden centers. Archaeologists report that hundreds of sites are being destroyed. You cannot buy Amazonian Terra Preta. You should not try. What was created over centuries of layered human habitation cannot be replicated simply by purchasing a bag from a market stall. But the principle behind it, the biochar core that makes it work, that you can make yourself, from wood scraps, corn cusps, rice husks, pruned branches, any agricultural waste that would otherwise burn or rot, you don't need a kiln, you don't need specialized equipment, a metal drum with controlled airflow, a few hours and whatever organic material you have available. That's the basic process the Amazon's ancient farmers used, and it's the same process that generates usable biochar today. The one thing you cannot skip, and this is where most people go wrong, is what researchers call charging. Raw biochar applied directly to soil actually pulls nutrients out initially rather than adding them, as its porous structure absorbs whatever is available. You have to saturate it first, mix it with compost, let it sit for a few weeks, let the microbial community colonize the pores. Once charged, it becomes a slow-release nutrient system that keeps improving over years and decades. This is not quick. Terra Preta was not built in a season, but neither is a dependable, self-sustaining food system. The fertilizer industry was built on the premise that soil is deficient and needs to be supplemented every season. Terra Preta is a 2,000-year-old counter-argument to that premise. It is sitting in the Amazon, still producing, still fertile, requiring nothing. It is sitting in a Cornell laboratory, confirmed and measured and peer-reviewed. It is sitting in the data from biochar trials in Argentina, Kenya, Indonesia, and Iowa, showing yield improvements and fertilizer reductions that no synthetic input can match over the long term. And it is sitting in your backyard, waiting for a few hours with a metal drum and some wood scraps.